So today's topic is recurrent networks. This is under neural networks. We have studied neural networks, single layer feed forward neural network, multiple layer feed forward neural network, and yesterday we looked at radial basis function networks, RBN networks. Today's type of neural network is a recurrent network. Can anyone tell me what do you mean by feed forward neural network? Feed forward neural network. Yes, please.
Information is going in one way, not
Very good.
only in one direction.
Very
Network
good.
taking input in only one direction.
Very good. So network information is moving from input to output in a forward direction. That's why it is called as feed forward neural network. If you consider recurrent networks, essentially they are a kind of neural network with cycle, whereas feed forward networks does not have any cycle. When an input is given, input travels through the hidden layers and finally reaches the output layer. It is moving forward in forward direction in the successive layers of input, hidden and output. Whereas this one, recurrent neural network, are an important class of neural networks. They have cycles, and this, suppose this is a node, this is another node, this is one more node, this is one more node. What happens? Information come like this, and information also goes to other like this. There is a cycle. This type of networks are useful for primarily language analysis applications such as machine translation and syntax analysis, semantic analysis. These are used for that, and also they are used for time series data analysis. Time series data analysis is related to analyzing the data which occur at a particular time on a particular date. For instance, you all are doing assignments. You know, when you submit an assignment, I receive a response, and that response, when I copy into sheets, Google Sheets, the timestamp is also added to every response. So that is like analyzing time series data. Okay, look at here. This is a recurrent network. Here, this output is going again as the input, and this output is going again as the input. From here also you can see output of this node is fed to the input again. This is the primarily recurrent neural networks contain cycles used for language and time data analysis, and trained using backpropagation algorithm. Can anyone tell me what is a backpropagation algorithm?
Going back, taking forward and backward or backward, something like it's
Uh-huh.
backward also. It takes information in backward direction, both directions. Also.
Yeah, you are right. Partially, what happens is when our neural network gives out output, some output is given by the neural network. That is called as a predicted output, and there is an actual output. If there is a difference between actual output and predicted output, that difference is sent back through back propagation algorithm. Why that difference is sent back? In order to update the weights, there are weights associated with every link. So in order to update those weights with respect to the error rate, the error is propagated back in backward direction. That is back propagation algorithm. This algorithm is used in feed forward network as well for the training purpose. However, this back propagation and this recurrent, they are entirely different. Recurrent is feeding the output of a node back as the input to the preceding layer nodes, whereas back propagation is giving out the error rate to from the output node to its preceding nodes, not in this manner. uh, Output node to its preceding, and these nodes to their preceding nodes. In this manner it happens, back propagation. And the primary use of back propagation algorithm is to train the model or to train the network. To train means what? To allow it to learn. How will it learn? It learns through iterations, by updating its weights. When it is updating its weights, it is getting closer and closer to the actual output. So that is what is done in backpropagation algorithm. Backpropagation is used for both feed forward network and recurrent network for the purpose of training, for the purpose of making the network to learn something new. What it is learning? It is learning the weights. After it learns the weights, the output that it generates might be equal to or closer to the actual output. And activation function is also used in recurrent net. A type of recurrent network is a hop-filled network. A Hopfield network was invented by John Hopfield, and thus it derives the name from the name of its inventor. In 1980s, this Hopfield network um, consists of n connected neurons, and all connections are weighted and symmetric. All the nodes are connected, and they all are weighted and symmetric. Weighted means what? There is a weight associated on the link between two nodes, that is weighted, and symmetric means the link is bidirectional. The weight is uh, from node 1 to 2 and 2 to 1 as well. And the activation of neuron is binary value decided by the sign of the weighted sum of the connections to it, and it is updated asynchronously and independently. Hopfield networks are a kind of recurrent neural network, and their output values are fed back to input in an undirected way. This point, if you please note down this point, that its output are fed back, similar to this type of configuration. The output is fed back as input. Okay, the structure the structure of Hopfield networks. There are nodes in Hopfield networks, and they are having binary threshold units that takes two different values for their states. It can be active or inactive. A node in a Hopfield can be active or it can be inactive depending on the threshold value. Threshold value means what? That is a boundary value. If we say that threshold is 0, then everything greater than 0 is in one category and less than 0 in another category. So threshold will determine the categories, classes. It is used to put data elements into different units. So if you look at this equation, activation of ith unit, it is 1 if, what is this? This is summation of wij. What is wij? Weight between node I and j into sj. Sj is state. If you first multiply and then take sum of all, and that is greater than some threshold value, it can be any value given, 0, -1, or uh, 10. For all j, for all j means I might be connected to 2, 3 j's. So for a node I, for all its connected nodes, we need to check this, and if it satisfies for all the connected nodes, its activation is 1. Its state is 1, and 1 means active and 0 means inactive. In Hopfield network, there are two states. Every node will be in any one of the two states. The two states are active, inactive. When a state will be active? When it gets a value 1. How it gets a value 1? If its weighted sum of all the connected nodes is greater than a threshold value theta. It can be any value. Otherwise 0 means it is inactive. So wij is the weight of the connection, s is the state of the jth unit, sj means not ith, jth state, and theta is threshold of the ith unit, and state 1 means active and 0 means inactive. And these are certain points to consider while designing this software network. No unit has any connection with itself, although they are connected with other nodes, but they don't have self connection. That's why wii is equal to 0. A node cannot connect to itself, and all connections between two units are symmetric and may possess positive or negative weights. Symmetric, both the sides weight is equal this side or that side, and it can be negative or positive. And each unit can be in active state or inactive state. Okay, here this is an example given. All the dark nodes are active units, and active units by dark means black circles, and this white or light white, okay, white circles. If white circles are inactive units, black circles are active units. And what is the connection? The connection here is positive. And this, if you consider black to be I and this to be J, then this weight is symmetric between this connection. It can be this way or it can be this way. And then the new state which can be derived is um, that the other node also turns out to be active or black, because here the threshold might be positive. If the threshold is positive, if you give that greater than 0, 2 is greater than 0, then in that case this node also turns out to be active. This is the new state. This is with respect to positive weights, and going ahead, this is with respect to the negative weights. Negative weights, -2 is the weight between node I and node J, and if you observe here carefully that the new state can be uh, this one or that one. What does it means? I consider this first one to be I and second one to be J. I, J both are uh, active, but because of this negative weight, in the next iteration, either I may become uh, inactive, or J turns out to be inactive. It depends on where and which unit is being considered for the next iteration. If you recall, all neural networks training happens in iterations, and the completion of iterations for all the data elements, all the data points or all the data samples is called as one epoch. Okay, this is a algorithm for the activation. When a unit gets activated, this occurs in iteration. So there is a repeat until statement. Choose a unit randomly and call it ith unit. In this example, first this I can be considered as ith unit, or jth unit can be considered as ith unit, in the sense that we may begin at this unit or at that unit. For ith unit, compute activation value as given below. Activation value is computed. How it is computed? Weight value between I and j is multiplied with the state of the j, and then for every j this process continues, and finally summation is obtained for all the j value. And if sum is greater than theta of I, theta is in this case the threshold value, and this repeatedly uh, occurs, these phases until the network reaches a stable state. This is an algorithm. This algorithm, what happens is, again, because there are several uh, units or nodes, what you can do is you can iterate for every node, and this algorithm has been obtained from this algorithm by applying certain simplifications. For instance, repeat a unit randomly, this is same. For the chosen unit, compute the sum of the weights. What happens here is, instead of putting a formula here, its description has been included in the simpler version of the algorithm. This both algorithms are same. There you use a formula, here you use the text. Look at this example. This is the current state. This current state, there are two active nodes or units. There are two inactive units, and then our process begins. Selected unit for current state. This arrow denotes which unit is being selected. If you recall, the algorithm chooses a unit randomly. Randomly, this unit has been chosen, and how you determine its state, whether it should be active or inactive, by using these weights. This unit is connected to these two units, and this unit as well, but because this is inactive, this is not being considered. These two are considered, um, I j and I and j, and when you take that 3 minus 2, you get 1. 1 is, if the threshold, the theta value is 0, then 1 is greater than 0, and this unit also turns out to be active. If you consider this example, here this black node is chosen randomly to figure out whether it, what is its state, what is its activation. So essentially what happens here is, it is connected to 3 units. However, among 3, only one is having the active state. So you are considering its weight, and its weight is minus 2, and because it is minus 2 and it is less than our threshold value, this black node turns out to be white, which is inactive. Okay, when a half-field network is said to be stable, it is said to be stable if no change occurs in the network. Consider this 3-unit half-field network. You choose, the algorithm chooses 1 as the first node to act, to trigger the activation, or second node can be chosen, or third node can be chosen, and then the process repeats. until the state of this network does not change. Therefore, at that point, that network is said to be stable, in stable state, because no further changes can happen. The stable positions for that network, if if that network is worked upon, stable positions can be any one of the three given here. Weight computation method. How to compute the weight? When training examples have to be provided with the weights between the nodes or the units. How that uh, is calculated? To figure out how it is calculated, you need to understand this formula. What is this formula? xi is an input sample into transpose of xi. This xi is a vector. Vector means it is a set of values. For instance, 0, 1, 1, 0, or 0, 1, 0 minus 1. Vector means more than one value. This xi is an input sample represented by a vector. That vector is multiplied with its transpose and minus m. M is the number of training input vectors. How many such xi's exist? If there are 3 units, xi will be 3. X will be 3. So you start with ith node and I plus 1, I plus 2, so 3. And I is identity matrix of size n by n. N is the number of units in the network. And the diagonal matrix will have a value 0 because uh, a unit cannot be connected to itself. Consider this example, x1, x2, x3. There are 3 vectors. These are 3 vectors. How are you going to compute the W weights? Xi means x1 into transpose of x1 and x2 into transpose of x2, x3 into transpose of x3, and sum of all of them minus m into identity matrix. Look at this example, how weights matrix is calculated. This is x1 and this is x1 transpose. 1 minus 1 minus 1, 1, and if you transpose it, you get in a row order, because in matrix you convert columns into rows. You are getting the row of this column. 1 minus 1 minus 1, 1 in row format. This single column turns out to be a single row and 4 columns. The size of this is 4 by 1 and size of this is 1 by 4 plus x2 plus x3 minus this. How many are there? 3. There are 3 input samples. and this is a matrix. This is x into x transpose. Result is this one, and similarly x1, x2, x3, all the three you have to perform summation on all these three. When you perform summation of all these three, finally you have to subtract with m into I. I is the identity matrix, and when you subtract this with this, you get this, and these are the weights. Look at here. There are three input samples. Each one has a four element data value. So there are four units. How they are connected? This unit 1 is not connected with itself. It is connected to unit 2 with a weight -1. Unit 3 with a weight -3. Unit 4 with a weight 3. This is unit 2. You look at here, this symmetric. This is x1 to x2 is -1. x2 to x1 is also -1. Likewise, if you check upon all these values, they turn out to be symmetric. In this, if you observe, x1 to x2 means unit 1 to unit 2. If you put out these elements, that matrix weights between them, you get this. And consider this one. Here x1, the first value is 1. 1 means what? Positive. Positive means active. Unit 1 is active. -1 means negative. Negative implies inactive. Inactive. 2 is inactive. 3 is inactive. 4 is active, because here you find 1. That is with respect to x1. With respect to x3, it is -1. 1 is negative, inactive. 2 and 3 are active. 1 and 4 are inactive. And these two are stable position. After this, even if you try to choose a node and apply that activation algorithm, no more changes takes place. Okay, that was about Hopfield network. Any doubts in Hopfield network? Next, going forward, Boltzmann machine. Boltzmann machine is a type of network which has been derived from Hopfield network. And when a Hopfield network is combined with a methodology or a technique called simulated annealing. Simulated annealing is a technique. When you combine this technique with Hopfield network, then what happens is it turns out to be Boltzmann machine. The meaning of annealing is that moving down from high temperature to low. And this machine was proposed by Hinton and Sejnowski. in the year 1986. The primary difference um, is that Boltzmann machine units contained in Boltzmann machine update their individual binary states by stochastic rule rather than deterministic rule. Uh, these are two jargons used in the field of artificial intelligence and machine learning: stochastic and deterministic. For instance, if I take class every day based on my availability, sometimes at 10 o'clock, sometimes at 11, sometimes at 12, then that is known as stochastic time. And if the time of the class is fixed, then all of you can figure out that every day there is a class at 12. That is deterministic. Boltzmann machine uses stochastic rule for updation of the weight, which primarily means that there is no fixed rule for updation. This formula is given. In this formula, 1 over 1 plus exponent e raised to delta e by t. Delta E denotes the sum of the active input connections and T denotes the temperature. Not every time the temperature of the network remains constant, and therefore the state activation is stochastic. It's not deterministic. If T value is fixed, in that case what happens is it becomes deterministic, because always it gives out the same value. If delta E is 2 and T is 10, 2 by 10 always gives same. Whereas if not always you have 10, sometimes 2 by 5, 2 by 10, 2 by 15, 2 by 20, 2 by 1. In that case, these p value may differ, may change. This technique is obtained from simulated annealing, this temperature value, because simulated annealing means it is about temperature. Temperature means it's not like in Celsius or Fahrenheit. It can be based on some value for that particular network. For instance, it can be 2, it can be 3, it can be any numeric value. So that temperature, this idea has been taken from simulated annealing. And Hopfield network, what is the idea of Hopfield network? That there are units, they are connected with each other, and the weights are symmetric, and there are active fields and inactive field units. That both the concepts have been combined into what is known as Boltzmann machine. What happens at high temperature? Units display random behavior while they behave as a Hopfield network at low temperature. Okay, that is about Boltzmann machine. Applications of Hopfield network. So going ahead with the applications, if you recall, Hopfield networks have active and inactive units, and After several iterations, it reaches a stable state, and hence that type of behavior can be, used to create a content addressable memory, which is known as associative memory. That is the first application in which half field network can be used as CAM, that is known as CAM, content addressable memory, CAM, or associative memory. These networks can also be used to solve constraint satisfaction problems, which are CSP. We looked at that puzzle problem, crypt arithmetic problem, that is CSP problem. And these networks are also useful for optimization and pattern classification. Optimization means trying to reach a better and better value. Pattern classification is given a pattern, for instance A. How do you draw a two slanting lines connected at the top, and there is a small line, horizontal line in at the center of those lines? That is a pattern. So a network that can classify a pattern. For instance, I showed you MNIST example. MNIST also has some patterns, handwritten digits 1, 2, 3. If that classification is, Hopfield network can be used for that as well. With this, we have done our unit 4 and chapter on neural networks. Any doubts? Okay, then uh, we'll meet on Tuesday. We'll start unit 5 on Tuesday. Please go through. If you have any doubt, you can even ask on Tuesday. Bye.